Hey guys, tonight I'm at the wood burner and this is going to be a quick video about the water quality, the chemical, and just how to maintain it. It's a quick introduction. I have a heat source one. If you have one of these, it's a great wood burner. I really like it, but I did modify some stuff. I kept burning out that dang little low water light, so I just plumbed in a little valve. If I hit that, and if water hits the top here, I know I'm good. If no water comes out, I'll add a little. Also, the door. If you have one of these, you've probably broken a hose in winter, dumped your water, and then just like cussed a whole bunch. So I've added some shut-off valves there and there. I've also plumbed the line so it points like that and like that. That way you don't kink your hose when you open the door. Also, I have plenty of hose, so if I do whatever, I can just cut off a chunk and re-put it on there without having to buy new hose. Extra hose. Makes sense, right? The other thing is, I like this little door latch doohickey, but if you look, that's modified. And the reason being, you open the door, it will catch it. And then just give it a little pull up and shut it. Super cool, right? All right, that's a quick look at the wood burner. Let's go do some chemistry and talk about water quality. Let me just clean that up real quick. All right, there we go. There are two main things we're looking at with an outdoor wood burner. One is the nitrite level. That is the anti-corrosive chemical that prevents your wood burner from rusting. The next thing is pH, which also is a corrosion inhibitor. Ideally, we want it above 9, but the range is 8.5 to 10.5 is adequate. These are the testing supplies that I have used so far. I started out sending it to a lab, and that was getting expensive, so then I bought this stuff, pH test strips, and this little test kit. Let me just show you real quick what those are and why I don't use them anymore. This is some sample that I took from the wood burner. There is a drain faucet on the back. I took 2 volumes of this and dumped it, and then the third volume I kept in here for a sample. Just to make sure there wasn't any sediment or anything collected in it, I wanted a clean sample representative of the entire volume of water in the system. Now this is a pH test strip. There's our color chart. Here's the strip. Water is about room temperature, should be good. Just gonna wiggle it around. Come on, and make sure it's nice and saturated. Then try to get a reading on here. This is where it gets kind of tricky. So it almost looks like it's around 7. So I'm not quite sure about that. Now, if you read the fine print, these do better in a buffered solution. The wood burner is not buffered, so your results may vary. Oh, hey, yeah, and these strips also expired over a year ago. Turns out test strips are good at most for 3 years from when they're manufactured. Okay. Next up is this wood boiler test kit from Wood Boiler Solutions. And I found this to be accurate for a little while. You take their sample, there's a line that somebody thoughtfully wrote on there, fill it to the line, take your sample, add it in there. Let's just give it a little shake. All right, I guess that's about as good as it's gonna get. Then the next step is to add this Nitrite R-9057 to it. And you wanna add the drops and then look for a color change. Okay, now, I already know the parts per million in this. That should be enough drops to get a color change. So you can see there's a little bit of color there, but let's just kind of swirl it around a little bit here. Swirl, swirl, swirl. And look, it's not changing color. This should change color. Based on the parts per million of nitrite in my system, this should be purple, but it's not. This test is no longer accurate. What I found happened with this stuff is it kind of like precipitates out. It separates, it goes bad. I don't know what the shelf life is on it. They don't tell you. But yeah, it's kind of annoying. There should be an expiration date or something on this. Basically, it goes bad, you don't know it, your tests are invalid, and you don't know. So I'm not a fan of this anymore. If you order this and you test right away, yeah, it's gonna work just fine. But once it's on the shelf for a year, maybe 2 years, I have no idea. But anyway, so this is junk now. So yeah. Let me show you what I do now. All right, so this is what I do right now. for the pH. So let's take a look at this. This is pretty simple. Turn it on. It's in Celsius, that's fine. We're about room temperature with this right now. It's on pH. So it's pretty easy. You want to get it fully submerged in the probe, make sure everything is mixed. And 9.47 is the pH, and that is accurate. That matches my lab value. Let's go to parts per million, and we are at 252 parts per million. So this is the latest thing that I found. I ordered directly from their website. Let me take a look inside. All right. So there's their little checker, and then there's 2 vials. I've already done some samples. There's also these reagent packets. Okay, so that's what I have been doing, and now that you're kind of all caught up, because I decided to make a video halfway through, I'm gonna just show you real quick what I'm adding to the wood boiler burner. It's this stuff right here. It is ChemWorld 830, and I had to decide how much to add to the wood burner. To do that, I drew back on my college chemistry. Okay, and now for some math. A windshield wiper fluid bottle is very similar, so I'm going to zero my scale with that and then weigh the ChemWorld solution. I'm going to take the weight of the solution and minus the weight of the water. The difference is 1,123 grams. I convert that into grams per liter, then times it by 1,000 to get parts per million of the solution. If my wood burner is completely full to 163 gallons, I find that 1 gallon of solution will increase the parts per million by 1,820, or if I add a quart, 455. Using this information, I'm going to add about 2 quarts. Now, I've done those calculations. I've added a very specific amount to the wood burner. I know how much water is in the wood burner. And now I just have to wait until tomorrow for everything to equilibrate. I can validate those numbers, and I will have some very useful information. So, see you tomorrow. We're just going to dump out the first one and take a sample. The chemical was added about 16 hours ago. It has had plenty of time to equilibrate, and I have my sample, which, as you can tell already, looks much better. There's actually some dye in it. So let's take a look at pH first. Looks like pH is about the same, 9.44. Good. It appears to be a buffered solution. The chemical added is maintaining that pretty equal pH. That's good. Let's go take a look at parts per million. There's 2,335 parts per million of total dissolved solids. So that's quite a bit more than before. All right, now it's time to do some dilutions. So we'll zero the scale with the beaker and measure out 100 mLs by weight. Apparently I only have 66 milliliters. That's fine. We're going to bring this volume up to 660 mLs next to complete the dilution. This is now a 1:9 dilution. Whatever result I get, I can now multiply by 10 to get the actual nitrate ppm. So next, I'll take my little checker right here, and we'll pop open the lid like that. I'm going to take a little bit of this off to make it easier to pour. And we're going to add that into this little cuvette. So we'll do that, and then also another one. Okay, so we have our 2 samples. One of them will be our control, and that's going to go into the tester. So in this tester next, we're going to turn it on, press the button, and wait for it to calibrate. There we go, it's calibrated. Then we need this reagent, which, look at that, has an expiration date. Very nice. And we'll cut on the line here. Okay. And that dissolves very well. Now there might be some bubbles in there, so next step is to open up our sample device, put that in. Now if you wanted to be super accurate, you'd use the same exact little cuvette here, but this will be good enough for our purposes. Now we wait 10 minutes and then take a test. You're supposed to be able to hold down this button and it starts a timer. I'm going to wait 10 minutes. That allows all the bubbles to settle, and then that will take a nice accurate reading at the end of that time, which it will display for 2 minutes. I will check back in 10 minutes. Okay, 10 minutes has gone by. 106 is my nitrite reading. If you do a quick calculation, that would be 1060. Final results. In my wood boiler, if I add 1 quart of this 830 solution, it will increase the parts per million nitrite by 480. By adding 1.93 quart, my resulting now is 1060 parts per million, which is up from 130 before. pH stayed exactly the same at 9.45. The total dissolved solids increased significantly to 2,343. If you have a wood burner and you want to apply these numbers to your system, if you can find out how much heavier the solution is compared to a gallon of water, you can make all these calculations. If you want a real simple answer where you don't have to calculate much, you can do a little bit of math and get that calculation to apply to any other thing. It's just a simple proportion. I'll put that right up on the screen here so you can see how one equals the other. All you do is add your gallons right there, do a little math, and you can calculate how much parts per million a quart will increase in your system. Anyway, I hope you got something out of this. I thought it was really interesting, and I'm glad I did it. Thanks for watching, guys, and till next time.